is continuing on factoring. We're going to start with the beginning part where we have to factor out a greatest common factor. So we look at the 2b squared minus 8b plus 6 like we did yesterday, and we see if there's something in common that we can factor out. What do you see that we have in common here that we can factor? We can factor a 2 out, okay? There's nothing else here that we can factor out. So when we do, we put the 2 in front of the parenthesis, and then we divide, and we end up with b squared minus 8 divided by 2 is 4b plus 6 divided by 2 is 3, okay? Now, you're going to see here in a little bit where you can actually take this trinomial right here and factor that portion further, and we're going to get to that in a minute. But for right now, I just want to continue to review what we did yesterday. So look at number 2 and see what we can factor out of each one of these terms. 2, very good. And just if they could just hammer just a little bit low. Okay. We factor out a 2. We're going to end up with n squared plus 6n plus 9. Okay, good. Okay, number 3. What do all 3 of these terms have in common? 3. Okay, so 3 goes in parentheses, and we're left with p squared plus 4p plus 3. Is she in there? Miss Boyd? There's no teacher in there? Okay. She probably just went down the hallway. Okay, perfect. Very good. All right. Number 4. Each one of these can divide by 2. And I know I'm going quickly, but this is what we did yesterday. Okay, we're left with, in parentheses,
x squared plus 4x plus 3.
Very good. Okay, number 5. Divide by 3. So 3 parentheses
X squared minus 5x plus 4.
Okay, very good. And last one,
3.
divide by 3. So 3 parentheses
N squared minus 9n plus
20. Okay. Now, like I said a little bit ago, you're going to learn here today how we can factor out these trinomials and go one step further, okay? But I didn't want to start that just yet. So, if you look inside, see how we have, in 4, 5, and 6, in the parentheses, you have a trinomial. Remember, a trinomial is a polynomial with 3 terms, okay? And the way we can factor that, notice in number 7 that that's basically what we have here, is we have 3 terms, x squared plus 12x plus 27. It's a trinomial. It's also, it has a degree of 2. Remember, the highest exponent tells the degree. And polynomials with a degree of 2 are going to be referred to as quadratics. These are quadratic functions. Is what we're going to be getting into. And so what we're going to do here is we are going to factor this, but if you notice, each of the 3 terms, they don't have anything in common. X squared, 12x, 27, there is no number or variable in common. So these get factored a little differently. Remember how on the previous test we had, you had 2 things and you might have had something like this, and then you had to multiply it out. Do you remember that?
Yes.
Okay, well, and then you would get something that looked like this for your answer, right?
Yes.
Okay, so now I'm giving you this, and you need to write this, basically is what we're doing. So I'm going to show you how to do it, and once I show you and you get the hang of it, it's rather simple. So the first thing you want to do is you want to think of factors of 27, like 1 and 27. 1 times 27 is 27, right?
Yes.
3 times 9 is 27, right? But you want to pick the pair that adds up to the number in the middle, the 12. What pair adds up to 12? 3 and 9. Okay? So what you're going to do is you're going to make 2 parentheses. You're going to put x in the front because you know that when you do x times x, that's going to give you that x squared, right? And then you're going to use these two numbers that you circled. It's a positive 3, so you're going to put plus 3 in one parenthesis and a positive 9, so plus 9 in the other parenthesis. If you were to check this and multiply this all the way through and combine like terms, you would get this. So all we're doing is we are listing factors of what's called the C term and finding the two factors that add up to what is referred to as the B. Now you're going to want to write this down real quick somewhere on your paper. Write ax squared plus bx plus c. We're going to use that a lot when we're dealing with quadratics. And the a is simply the term, the coefficient in front of the x squared, the b is the coefficient in front of the x, and the c is the constant. In this case, the c is 27. The a is 1 because there is, the coefficient in front of x squared is 1, right? And the b is positive 12, right? All right, number 8. All right, so let's look at number 8. So remember, our A here is 1, our B is 10, and our C is 21. So we know we're going to have two parentheses. We're going to have x in each one, and we want to think of factors of 21 that add up to 10. Can you think of two numbers that when you multiply them, they give you 21, but when you add them, they give you 10? Kennedy? 7 and 3. 3 times 7 is 21, and 3 plus 7 is 10. So positive 3 and positive 7. Yes?
When you put it in the parentheses, does it matter what order they go in?
No, you could have put plus 7 and then plus 3. Yep. Okay. Let's look at number 9. This one, see if we can do this one in our head. We're going to put x and x here because the first term is x squared. And then we have 36. So two numbers that multiply to 36 but add up to 12. Okay, so positive 6 and positive 6. But anytime you have more than one parenthesis that's identical, now if one had a plus 6 and one had a minus 6, they wouldn't be identical. But these are identical, x plus 6 times x plus 6. So anything times itself can always be written as that squared. So we should then write this as x plus 6, the quantity squared. What that means is x plus 6 times x plus 6. When you say the quantity, that means the entire parenthesis. That's how you read it. If you had said x plus 6 squared, you would be saying this right here. And x plus 6 squared is x plus 36, and that's not the same polynomial that we had, is it? So you wouldn't say that, okay? You would say x plus 6, the quantity squared. Okay, I want you to try number 10. Did you guys get it figured out? Okay, so x plus 3 and x plus 3. So you can write that as x plus 3 squared. Very good. Okay. All right. I want you to take what you just learned and try to see what you can come up with, and you can work at your tables for number I'm sorry, I'm not where I thought we were just yet. Let's look at number 11 together. Because we don't have, because in the first term has a number other than 1 in front, why don't you first see if there's a GCF? Is there a number you can take out, a greatest common factor between the 3n squared, the negative 27, and the 60? What? 3. So we're going to factor out a 3, first of all. Now remember, when you factor out a 3, it goes in front of the parentheses. Then we're left with n squared minus 9n plus 20, right? Remember me telling you earlier that we were going to learn how to factor this inside the parentheses? Okay, well we just learned that, didn't we? So we're going to take this a step further. We're going to leave our 3 alone, and we're going to factor this big parenthesis down into 2 parentheses. This n squared is going to have an n in each of the fronts of the parentheses. And then remember, we have to look at this 20 and say factors of 20 that add up to negative 9. So 2 numbers that multiply to positive 20, but add up to negative 9. What? 4 times negative 5 would be a negative 20. Negative 4 times negative 5. A negative 4 times a negative 5 would be a positive 20, and it would add up to that negative 9. So perfect. So minus 4, minus 5. And this is your answer. Okay? So I want you to try number 12. And I'm going to see if there's a way that I can pause this. I don't know. I may have to stop this and do this in 2 parts. This is 7-2, right? Good idea. Part 1. Okay, well.